In this video, I will show you how to solve systems of conic sections. I'm talking about circles, ellipses, parabolas, and hyperbolas. In this case, our conic section is the first equation, which is a circle. We know this is a circle because our x squared and our y squared both have the same coefficient, positive 1, both times. Now, the second equation is actually not a conic section. This is just a line. Nothing is squared. You just got y equals mx plus b. So we're dealing with a circle and a line, and we are looking for the intersection point or points between these two figures. So how are we going to do that? Our two main tools are substitution and elimination. This would be an easy problem to use substitution. Okay, so I've got x squared plus y squared equals 20. All right, that's one equation. And then I've got y is equal to 2x. So substitution, because y equals 2x, I can take this 2x and I can substitute it for y in the first equation. So this equation then will become x squared plus 2x squared is equal to 20. Now we have all x's. So this will become x squared plus 4x squared is equal to 20. Combining these like terms, I've got 5x squared is equal to 20. And then I'm going to divide both sides by 5. So now I have x squared is equal to 4. If I take the square root of both sides, I have x is equal to plus or minus 2. Don't forget the plus or minus whenever you take the square root of both sides. So this is half of my solution. So as I begin to build my solution set, I have these two x values. I have a positive 2 and I have a negative 2, plus or minus 2. That means I have 2 comma something and negative 2 comma something. I need to find the y values that go with these x values. So the way I'm going to find those y values is by using this equation right here. Okay, so let's start with positive 2. And let's let x equal positive 2. In that case, we have y is equal to 2 times 2. So y is equal to 4. So that gives us an intersection point of 2 comma 4. So next, let us let x equal negative 2. Okay, now the equation becomes y equals 2 times negative 2. So that means y is equal to negative 4. So that gives us another solution, another intersection point of negative 2 comma negative 4. So this should be our solution set. Well, let's take a glance at desmos.com and see what this system actually looks like. And let's identify these intersection points. So take a look. Here's our circle and our line passing through it. And we have an intersection point here at 2 comma 4. And we have another intersection point here at negative 2, negative 4, which is exactly what we found when we did this by hand. Okay, now in problem number 4, the first equation is a parabola. I know this because only one variable is squared. The y is squared, the x is not squared. That makes it a parabola. The second equation is the equation of a circle. Okay, this is the standard form of a circle. Notice the coefficients are the same, 1 and 1. So you know this is going to be a circle. Now, are we going to do substitution or elimination? Well, at a glance, there are two things that tell me that I'm going to do substitution. First of all, with the parentheses and everything, the elimination method is tough to do. Also, substitution is going to be relatively easy if you can find part of the equation that's the same in both equations. So in this case, it's jumping out at me that we have this y plus 1 squared, and then we have another y plus 1 squared here. Because those are the same, I can do a substitution, and it won't be that bad. So let's give that a try. First, I'm just going to recopy these equations sort of side by side. All I've done was rewritten the equations side by side. So since y plus 1 squared is equal to 8 times x plus 1, I should be able to take this expression, 8 times x plus 1, and substitute it into the first equation in place of y plus 1 squared, since y plus 1 squared equals this. So that's what I'm going to do. So that's going to give me x plus 2 squared. But now instead of y plus 1 squared, I'm going to write this. So I'm going to have plus 8 times x plus 1 equals 25. The advantage of this is that I have all x's now. X plus 2 squared is the same as x plus 2 times x plus 2. And then the rest of it. 8 times x plus 1 is equal to 25. If I double distribute, or FOIL, whatever you want to call it, I'm going to get x squared plus 4x plus 4. And then I'll distribute here, so I will have 8x plus 8 is equal to 25. Okay, now I'm going to combine like terms. So I've got x squared. I'm noticing that we have 4x and 8x, so that's going to be 12x. And then we have 4 and 8, so that'll just be 12 is equal to 25. Time to subtract 25 from both sides. I'm going to get 0 over here. So that's going to give me x squared plus 12x minus 13 is equal to 0. So this looks like it's going to be factorable. X squared is only x times x. 13 is 1 times 13. It's a prime number. I need the middle to be positive 12. So if I let this be negative 1 and I let this be positive 13, then my inner and my outer will make positive 12x. So this is good. Negative 1 times 13 is negative 13. So we factored it. Now I will find solutions by setting these factors equal to 0. All right, so this means x is equal to 1. Subtracting 13 from both sides, x is equal to negative 13. All right, I am halfway to my solution. As I build my solution set, I recognize that these are both x values. So that means I have 1 comma something, and I have negative 13 comma something. So I have my x values, but I need the y values that go with them. So the way I will find my y values is by using the other equation. Okay, so one by one I will substitute in the two x values that I just found. Okay, so that's 1 and negative 13. So let's start by letting x equal 1, and let's see what we get for y. So if x is equal to 1, then this equation will become y plus 1 squared is equal to 8 times 1 plus 1. All right, I'm letting x be 1. So that's y plus 1 squared is equal to 8 times 2. So y plus 1 squared is equal to 16. Taking the square root of both sides, I get y plus 1 is equal to plus or minus 4. Don't forget your plus or minus, or you will only have half of a solution. Subtracting 1 from both sides, I get y equals negative 1 plus or minus 4. All right, always put it in the front of the plus or minus like I just did. Now this plus or minus means that I have negative 1 plus 4 or negative 1 minus 4. All right, that's what the plus or minus means. So that means I have y equals 3 or negative 5. Okay, so I started with an x value of 1, but I got two y values out of it. The way I can make that work, since I have this same x value but two different y values, I just need to copy the x value twice, once for each y value. Okay, so that means I'm going to have 1 comma 3 will be a solution, and I will have 1 comma negative 5 will be another solution. All right, so I have two solutions that have an x value of 1. So now let's go back and do that again for the other x value, which was negative 13. So we're going to go back and we're going to let x equal negative 13. Okay, so let x equal negative 13. So this equation right here will become y plus 1 squared is equal to 8 times negative 13 plus 1. All right, I just put negative 13 right there. So that's going to give me y plus 1 squared is equal to 8 times negative 12. So I've got y plus 1 squared is equal to negative 96. Well, wait a minute. This is not possible. You can't square something and get a negative number. So I'm not going to get any solutions from this. All right, if you think of it another way, my next step would be to take the square root of both sides, right? So imagine that I took the square root of both sides. You can't take the square root of a negative number. That would give me imaginary numbers. So no solutions from this. So that means that as I was building my solution set down here, I had this negative 13 that I thought might give me solutions, but it doesn't. So this is my complete solution set right here. All right, these are the only 2 points of intersection. So let's take a peek at desmos.com and see how this system looks. Let's look for these intersection points. All right, so take a look. We have our circle intersecting with the parabola, and the intersection points are here at 1 comma 3 and here at 1 comma negative 5. And that's exactly what we got when we solved it by hand. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.